Okay, the last thing we're going to look at is a piecewise function. For this piecewise function, I'll first of all go ahead and sketch it up, and then we'll go ahead and look at all the limits that are listed. Okay, this piecewise function, if you don't want to copy this down in your notes, remember that you have Jing, and from Jing you can just pop in right up here and tell it that you want a screen capture. I don't know if Jing will let me do this while I'm actually using Camtasia already. See if it will. Nope. Oh, here it is. Yep. You could go ahead and just grab this graph. Tell it you want to just take a quick image capture, and then it's in your clipboard already, and then just copy and paste it into your notes. So that's kind of cool that you can do that and you don't have to spend all your time copying it. So for the first question I want to ask here is, what is the limit as x approaches 0? Well, we can see from this graph here that there's a lot going on. I can approach 0 from the right and I can approach 0 from the left. There's a lot of stuff going on. So let's go ahead and take the limit as x approaches 0 from the left of this function, the limit as x approaches 0 from the right of this function, and see what's happening. Now remember, this is so important. The limiting value does not have to equal the functional value, and a point does not have to be defined, meaning it can be a hollow point in order for a limit to exist. So let's go ahead and check the limit from the left. As I take the limit from the left, my y value is getting closer and closer to 0, and it actually equals 0 for this case. Now let's go ahead and look at the limit from the right. Kind of follow this graph through, jump up, and the limit from the right is 4. Now notice I don't actually equal 4, I just get very, very close to 4. Now the limit from the right does not equal the limit from the left. These are not equal. Therefore, the overall limit as x approaches 0 of this piecewise function does not exist. The limit from the right does not equal the limit from the left. Therefore, the overall limit does not exist. Okay, let's go ahead and ask another question with limits as well. Okay, this time we're interested in the limit as x approaches 2. And again, I need to check it from the left and I need to check it from the right. So the limit as x approaches 2. Here's x equal 2. Okay, as I approach 2 from the right, my limiting value is 1. As I approach 2 from the left, even though I have a jump here, it's a discontinuity, my limiting value is also 1. So the limit from the right equals the limit from the left. Okay, so these are equal. Therefore, the overall limit as x approaches 2 is equal to 1. So our first one didn't exist. This one does exist. Let's go ahead and find another value. Okay, for this next example, I'm looking at the limit as x approaches 4. Well, again, I check the limit from the left of 4, the limit from the right of 4, and let's see what's going on. So here's 4. As I approach from the right, I'm getting closer and closer to 3, but I never actually equal 3 on the y-axis, but that's okay because a function does not need to be defined at a particular point in order for a limit to exist. So the limit from the right is 3. The limit as x approaches 4 from the left is 3 as well. They agree. They're equal. They agree. So therefore the overall limit as x approaches 4 is equal to 3. Now in the next one we're going to be looking at, it might not be as obvious what's going on, so let's be careful with that one. Okay, for this last one we're taking the limit as x approaches 3. And again, in order to determine a limit, you take the limit as x approaches 3 from the left, the limit as x approaches 3 from the right, and if they agree, the overall limit is equal to that limiting value. If they don't agree, the limit does not exist. So let's go ahead and take the limit as x approaches 3 from the left. As we approach 3 from the left, and again, x is equal to 3, my limiting y value is equal to 2. As we approach from the right, we have the same thing happening. I have a limiting value of 2. They agree, they're equal, therefore the overall limit is equal to 2. So that's my limiting value there. So in order to determine a limit, first thing to know, a hollow point is okay. A function does not need to be defined at a particular point in order for a limit to exist. Okay, so there's a summary of 4 different limits what we found there. So kind of here's our big takeaway, big comment of the day. A function does not need to be defined. At a point in order for the limit to exist at that point. Hollow points are okay. In section 2.3 that we're going to be looking at, we'll be looking at more of the algebraic approach to determining limits. And that's a pretty straightforward, easy section because, again, it's a lot of repetitive algebra and then plugging in to get the numerical approach.